Okay, then we start with the last session of our second day of the working group updates. It's on the systems work group, and it's like the other ones. We have the idea on what is the goal, where do we start all this, what have we achieved during the year. There's quite some nice achievements, I would say, and we also had quite hard times in some of aspects. So we started activities which we stopped. We'll also discuss something about this and say where, as an outcome, we are today, what we plan for 2024, and where we search for collaboration opportunities. So the overall goal is to enable other working groups within ELISA to put their safety claims towards Linux in a wider system context. We figured out that a lot of work groups look into their use case, into the Linux environment, and as we have so much focus on Linux, we sometimes forget that there's something left and right. Then let's assume you build your perfect Linux system, you have it safety certifiable, you're done, and then you want to bring it into a product because somehow you manage to get a safety element argumentation and figure out, well, suddenly someone pops up with a hypervisor or someone comes with an RTOS and there are interactions with it. And that's where we jumped in and said, well, if we look into several industry architectures, there's more than just Linux and there's always a context around it. And while we originally wanted to have the systems work group as an industrial or IT work group, uh, it's basically not the systems one. And yesterday, Gab was showing this slide also with the slide modification for the architecture work group because it heavily interacts with elements. But what you could really see is the use cases look heavily into the plain Linux, same does Linux features and architecture work group. We have also groups which look wider, like the tools investigation and the open source engineering process, which put a wider picture. And we want to bring the things to life in the systems workgroup with an exemplary system, with an example system. And the mission and this picture could look like we will just look into the ELISA scope, but you see already here also pictures from the CIP, AGL, or Sapphire project sent in there. And we do actually have an interaction with other communities, maybe a little more than some of the other work groups currently because our system has the context. And so we are really in close exchange with the Xen project, with the Sapphire project. We went and interacted with the open source community. So we went to the Linaro Connect discussing about Sophie parts. We had this exchange with the Eclipse SDV because they also heavily rely on the containerized, virtualized environment, the AGL use case, keeping in mind also with connections to automotive. And then, yeah, we also had participants from Yocto because we still want to see how much can we build with Yocto also that we maybe build the Xen directly in Yocto and see how we generate the SBOM. I have a slide on the SPDX activities because we said, well, if you create something, you may also want to have an SBOM for safety, not only know what's in there from a license perspective and a little bit left and right, but also to certain traceable, exchangeable formats for safety parts as an SPDX. And yeah, Linaro I already mentioned. And it's overall always the idea that we bring different discussions, topics together to get new ideas so that we all learn from each other and go home with a little bit more knowledge. And this said, to talk about some achievements, yeah, we have the SPDX FUSA subgroup started. It started in the systems work group that we discussed about. Well, how does the system SBOM look like for functional safety? What elements should get in? And then we said, well, where is a better place than discussing it with ELISA to get the people into ELISA? We thought, let's go where the experts on SBOMs are, where they know about standards. So we went into SPDX. And here a formal subgroup was started. It meets on Fridays. Presentation about some of the work will be there on at FOSDEM also. So I have a slide on this later. We also had related demos at CS. So it was not directly ELISA demos, but we were preparing things, discussing, and for example, EPAM was showing their quite comparable system, which we also worked on in reproducing and keeping it in. We started this year with the Renesas Arcar H3. Then we had to migrate to our Xilinx as we had some hardware issues. But this ended up in a demonstrator setup. I will also show a picture on this a little bit later. showcased this also. We went to the Embedded Open Source Summit in Prague, presenting technical work there, set the wider scope also, and discussed it on plumbers. We also went to the Exida Symposium to explain the different approaches of the different projects for functional safety. And then, yeah, thanks to support from the tools work group again, and also to CDEEP, we have the continuous integration enabled for system images already. First underlined part was on the SPDX. So I put the link in here. I guess participants are welcome. You can also follow the live stream, which is on SPDX Fuser together with, I guess, the Sapphire project, because they also work on it. It shows it's not only Linux, it's about the whole system part. So here's also the link to the schedule, and you can subscribe to the mailing list, similar like it's possible for the ELISA parts. But if you're also interested in SPDX, ASBOMs, and so on, that's the place to be for safety. Right. To move to something else in there is the hardware demonstrator setup, which I was mentioning. You can see this larger board on the right. This is the Xilinx XU 102. And yeah, what were reasons to go for this board? It started with Stefano Stabellini as Xen maintainer. He did a demo and he was bathing his demo on a XU 102. That was hardware he had at his desk. And in our pre-discussions, which we had with other work groups and with also with the Renesas boards, with looking into it, we figured out it's good to get things started if you get good support and use setups where people are already familiar with. So we decided for this XU 102, put equipment in there, different boot types and so on. So here's some links. You can have the full presentation also watching it on YouTube from the EOS part. And you can see there's a lot of equipment also which belongs to a system. That's why I just said, okay, we have the board, we have the software, but there's so much more like documentation, SD cards, USB, Ethernet devices, then environmental things like DHCP servers, console, keyboards you may use, screens. Well, this is all ending up in a setup. And we want to bring it to life. You saw that I I come from Bosch, and it was not so easy to carry around always the hardware. We didn't get it too stable yet to carry it and fly it all over the world. But we had a very nice chance to give a first trial and had the sponsor by this. So we put this in a nice case and could really carry it around, having it battery powered so that it's just like starting the system and showing various use cases. And exactly these use cases are described in the presentation Thomas, a colleague of mine, was giving at the Embedded Linux conference last year in Prague. So here's the YouTube link on it. It's a half an hour worth of getting the understanding on what challenges we had in detail, uh, how we overcome them, what we did, what are the use cases, how they look into it. And they also point to a lot of other YouTube material where you can see the different way of how systems boot and how the device interaction, power virtualized devices, naturally mapped devices fall into such systems, what it means. Uh, and I said there are some challenges. I took the hurdle picture again. Our main challenging point, I would say so far, is really to get a good GPU virtualization support. We see how much has been done in the field of virtualization for the CPU, interoperability if it's a native or virtualized system, but really get a good supported GPU driver which runs in a virtualized environment, can be used as para virtualized, and uh, this is really more complicated. And I say what we need here is something where we can have a community support without the need of an NDA. So our first trials went up to the system CI, and then we figured out it's not just about kernel headers and so on. So there was much more which was needed under an NDA to really bring the demo forward. And this was one of our fails. We say, okay, we started, but it was not properly handleable. And even with some support, which is really good from EPAM guys, also there we could reproduce things, but still it was at the end bound to an evaluation license agreement needed. So we dropped this. We went to the GPU support from Xilinx, but also figured out here are limitations just on the performance of the hardware. This is also hardly possible there. Maybe we end up at an example where we don't need the GPU that much. Then still community hardware would be needed because the Xilinx board is very expensive. And the second part, we did this last year. We want to get the system SBOM, but we had so many hardware struggles setting up a demo, getting things up and running boards that we haven't yet enabled the system SBOM. That's something which comes as one of the key activities, and I guess that's on the next page. So we currently enhance our CI to include an image boot with QEMU. So you saw a hardware board, but the nice thing about Xilinx hardware is if you use a Xilinx QEMU, you can really use the hardware images which are generated, put them into a QEMU, and get it booted. You will have naturally some limitations on interfaces. Maybe you don't have an I2C bus or an SPI bus or whatever around, but you can still see that the images are working. And this will help us similar to have a reproductional scenario like in the automotive workgroup. Then the system SBOM generation is a thing which I mentioned. The third point in the current activities is to have also the setup prepared for exhibitions and fairs so that we get things showcased, that there is a hardware which can be carried. Maybe we start with having it in Germany. We will share the description how to build your own system. Here, of course, it could make sense to go for a little bit cheaper hardware than the Xilinx XU 102. So this is there. And I just showed you that we have currently already the systems workgroup CIs, 160 plus builds in there. We push packages and create things. And this all stops here at generated images. And if you remember the presentation from the automotive workgroup, we have QA testing of QEMU images, and we have the full dependable flow. And here we just see the build works, not even the boot. And our main issues, which we had in the part, were actually not build issues, but related issues due to changes in external dependencies, which were hard for debugging. So we really would like to get to a bootable system and to also see how can we make the hardware more accessible, because also if there's enough hardware to be placed in labs or so, this can also help us to get testing more reliable. And the first step maybe to get image testing via QEMU asset, and that's where we currently have our ticket task open to get this forward. Yeah. Another thing, the SBOM generation, I saw this, I said, I presented this picture already before, so we have the generate SBOM part in the Meta ELISA, did a lot of work there, but this is not yet to be enabled as part of our current activities. So we want to have a similar view also for the systems workgroup and not only the Meta ELISA CI. Further plans for 2024, first of all, enablement of additional hardware, in best case with graphics support, depending on if there is nothing like such or the use case is proper without graphics, we don't need it. And we really need to enhance the feature set on the example use case. So we want to show how systems interact, how they behave. And so far we made up examples on how Ethernet devices sharing works, USB device sharing work, and this may not be what you want to see in the industry, what you see as a real use case. It's more like playing around, experimenting, getting used to the system. And therefore we considered like what could be a use case. And the first consideration was, for example, looking into LF Energy and the Everest project, because this gives a link to industry support and industrial application because of the charging stations, but also has connectivity to mobility environment, to EV car, so electric vehicles. And this will also result most likely in a stronger demand for Sapphire activities, because so far we mainly interacted with Xen community. We put a little bit of work on Sapphire, but not such a strong case as with Xen. So we definitely want to have a closer interaction with Sapphire. And then some two parts which are still in there. So we considered containers as one part, which is getting more important, but also how do we treat AI? Artificial intelligence is part of a system SBOM, and what is the importance for safety critical systems? And I believe here fit is quite good in the systems work group. We need to get it forward, kick it off, and see what we make out of it. So that's something like a plans for 2024. Details roadmap still need to laid out over the next weeks, let's say. Collaboration opportunities basically falls into the plans. We really love to get suggestions on good community hardware, maybe also with AI accelerators. We talked about the Creo 260, but there may be other boards as well. So at least the Creo 260 from Xilinx will reduce the costs by 2/10 of the other board. There may be a good chance from NXP or TI, which also bring automotive, bring industrial hardware. Renesas could be in there as well. Right, this is the part in there. Then we want to bring something ported to new hardware. In best case, we want to have two kind of hypervisors, two kind of Linux distributions, two kind of RTOS, and two kind of hardware to really show how system interfaces are, how things interact. And here also support would be welcome. But first step could be to reproduce what we have prepared. In automotive, it worked well that people picked up the documentation, tried to reproduce, created issues, gave feedback on where do we have to improve, that it's really easy for us to reproduce things. So that's a part where we stick to support it because it's a link to the mailing list. So if you want to scan the QR code, if you have later on the slides, you can also just go into the clickable link here for the meeting and the mailing list. Right. This would conclude the things I wanted to say, and with time for a few questions, I guess. And I see a first one on the chat, which says, "Can you elaborate on your system bomb thoughts?" Yeah, what we would like to see there, system bomb goes quite far, most like it's not a defined name as such, at least not for me. System bomb for us means what are software elements and touching parts in it. So our first system SBOM part would be our system bomb to go for, say, what's in there from Linux, what's elements, libraries, parts are used in Xen, what are used in Zephyr, how do I get a proper overview of how do they generate SPDX style of SBOM? So this is maybe also, we currently focus on the SPDX parts. What do they mean for safety? And yeah, as currently, for example, we don't have AI in. If we would get an AI in, we would say, okay, how do we get the AI elements, modules, parts, IP in there? What does this mean from a bill of material? How to list them? How do we treat vulnerabilities with not only AI, but the other parts? And that's currently where we look into. I don't know, Kate, if you want to add a word on this also. I mean, you're supporting the systems work group and do a lot also on the SBOM work. So if I missed
I think
something.
no, you caught most of it. The other thing too is as more capabilities get added into SPDX, probably trying to bring them in here. Things like interactions with the hardware and interaction with services is work
Yeah.
that's ongoing development in SPDX. And so any of these systems is obviously running on hardware, and being able to link the software to the hardware appropriately is probably going to be useful from a system analysis perspective. So that's another dimension, as well as the AI, as you point out, and data sets.
What I also found very interesting was I came through this beginning of the week. If we have QEMU booting and physical hardware, and both rely on the same images, so you basically don't change the software, but you run the software on different type of hardware or simulation. What impact does this mean? And I think this is also an interesting topic for the SBOM
Yeah,
discussions.
and that's kind of where the hardware group is going, is making sure we can represent virtual hardware as well as physical hardware. So it's going to line up, I think, eventually down the road. But we just need to get more of the taxonomies figured out before we can start to prototype things a bit more in that group.
Exactly. And if you think about virtual hardware, I mean, this virtual hardware is built, it's configured, it needs an own BOM, and it actually has a software BOM as well, which belongs to the system, because if you want to reproduce this system and you have an ASBOM for the system, you need the system virtual hardware BOM as well to come to the same conclusion, see what does it mean. And if this will really run on something, then, well, it's open a large stack possibility of things to do. So here we go. And we open the ASBOM box.
Okay.
Yeah. Any other question? Was a good one at least. And I hope it was answered sufficiently for you. Hey,
There you go then.
and thank you so much. We are reaching the end of the